Here is our sorted array. 2, 5, 8, 12, 16, 23, 38, 56. Suppose our target is 16. The lower bound question is this. What is the first position whose value is at least 16? Here 16 sits at index 4, so that is our answer. This little idea is the building block for many search problems. Because the array is sorted, we can halve our search each step. We look at the middle value. If it is smaller than the target, then the middle and everything to its left are too small, so the answer must be further right, and we move our low marker past the middle. Otherwise, the middle could be the first value that is big enough, so we keep it in view and shrink the high marker down to the middle. When the two markers meet, low is sitting exactly on the first position that reaches the target. Low starts at 0 and high starts at the length of the array, one past the last index, so an answer of not found lands cleanly at the end. While low is below high, we take the middle. If that middle value is still under the target, we push low to one past the middle. Otherwise, we pull high down to the middle. When they meet, low is our lower bound. Let's build lower bound in a live editor, one block at a time. We start low at 0 and high at the length of the array, one step past the last index. While the window is not empty, we look at the middle position. If the middle value is too small, the answer must be to the right, so we move low past the middle. Otherwise, the middle might be the answer, so we keep it and shrink high, and finally return low. Now, let's test it and hit run. There we go. For target 15, the first value that reaches it is 16 at index 4. 16 itself is also at index 4. And 60 is larger than everything, so we land at index 8, just past the end. Here is the whole shape. Set low to 0 and high to n. While low is below high, take the middle. If the middle value is under the target, move low up. Otherwise, move high down. When they meet, return low. Each step throws away half of the remaining positions, so the number of steps grows like the logarithm of the array length. That is order log n time. We only keep 2 markers in a middle, so the extra space is order 1. 3 things to remember. First, start high at the length of the array, not the last index, so a target bigger than everything lands neatly at the end. Second, notice the asymmetry. On the low side, we go one past the middle, but on the other side, high becomes the middle itself, because the middle might still be the answer. Third, a return value equal to the array length simply means no value was large enough.